Make sure all that works in the evaporator. You want to come down here and make sure your condenser is clean, because you can't check your charge without a clean condenser and a clean evaporator, and making sure both sets of fans, if they have them, are going in the right direction, blowing the air over in the correct. How do we know when this thing's blowing correctly? Well, the condenser pulls air in across that coil right there. Okay, it pulls air through there. If that's dirty and block, air can't be pulled through there. Next thing, after I make sure it's clean, I check the fan. I make sure it's running at the proper RPMs. I make sure it's running at the proper amps. I just put my amp meter on it, and just by the amps, I can tell if it's doing its job or not. If it's slacking, you know, it ain't gonna run as high as amps. If it's, you know, it all depends on it, you know. But you gotta look at it. The amps do tell the story. And the other thing is, you got to make sure it has the right blade and the air is moving correctly across the way the coil is designed, okay? Which is usually pulling air through that coil and over the compressor. Now that I've determined that I don't have no ice and my condenser's clean, I'll run it through a system check. And I'll get it to run, okay? Now, what I'm going to do then is I'm going to check my gas, which I have a sight glass right there, okay? And if that is full of gas and running, then I put my amp meter on the compressor and I know my running load amps. That'll give me to let me know how my charge is doing on the compressor right down to the T. Okay, I don't even have to throw my gauges on it. I can tell you right then, just by my amp draw and my sight glass, that I don't need to even throw gauges on it, okay? Okay, so now it's icing. It iced up, so something took it out. So we'll start looking at, now that the system's running, we'll start looking at controls. Thermostats, cut in, cut out, pressure controls, and time clocks are all ran in series. You know what series means? That means that wires ran through them in series and can be made or break by any of the controls because they're in line with one another. Understand that? Even like a fuse, because a fuse is in line. Okay, so everything's wired, so it's all wired in series. Okay. So now we know this thing does not have a thermostat. So what we want to make sure is, now we may have to get my gauges out and put them on. Because when we go to set the cut in and cut out, it's done by pressure, not temperature. So first thing you want to make sure is when you put your gauge on there and you're adjusting it, that when it goes off, it doesn't pull such a vacuum that it's in a vacuum. You want to pull like 5 to 10 pounds of pressure and go off. You don't want this thing going off, pulling a vacuum every time it's hard on the compressor. Okay. And the other thing is if it's set right, there's no way it can do that, because as the pressure drops on the evaporator, that's when it tells it when to cut out. Because what happens is when it gets cold in the box, remember when you add cold gas, what? It retracts. So it takes less of it, right? So now the pressure's going down. So the evaporator pressure's going down. It's going to cut out at a certain pressure, wherever it corresponds to whatever 38 degrees is with MP39. And what it'll do is it'll cut off. And then what you want to do is just to cut in, to come in about 4 to 5 degrees warmer, and then come back on and then pull temp back down to 38 and then cut out. Okay, and you don't want them so close together that the compressor comes on and off, because it'll kill the compressor. Okay. All right. Now, let's say we determine that it is going in and off at the proper temperature, cut in and cut out differential. So that isn't the problem. Guess what? We didn't look at the time clock yet. So we open up the time clock and we look to see, oh wait, there's no pins in it, or oh, the power, it gets power but it isn't working, or I put it in a defrost and it doesn't come out of defrost, or it just never goes into defrost at all. That will cause it to ice up. So getting that to work properly and make sure it's going through its defrost cycle can be the problem. Okay, let's say the time clock's working good. Well, this time it was my cut in and cut out. Well, guess what? I either have to get it to adjust or I need to replace it. But I need to have it cut in and cut out at the proper pressure in order to make temp, because if it runs continuous, because it ain't going off on the cut off and cut in, it will ice up too. Okay, you understand that? Because they're in series. And one just detects pressure on one side, and when it gets to a certain low, it just shuts off. And when it goes up to a certain high, it cuts back in. And basically that controls the temperature. Okay, so there you have it. Let's say what else would cause the evaporator to ice up? Well, if the low, because you put your gauges on there and you find out, well, guess what? I have no suction and I have no head. What would cause no suction and no head? Well, the only way it would have no suction and no head is if it had no gas, right? Because it ain't got nothing to suck, right? It ain't got nothing to push, right? So guess what? And so what you have to look at is it iced up because it's low on charge, okay? But I'll tell you, as soon as, if you do the steps I do, I put my amp meter on and I look at the sight glass and I check the book and see what my running load amp should be, or I call the supply house and give them the model number and they'll give me the running load amps, okay? It's a free service that they provide if you just ask them, and that's how I know what my running load amps are. And I look and see in my sight glass that I have bubbles and I got low amps. Guess what? She ain't doing the work she should do, and it'll run hot and go off on thermal overload sometimes when it's starving for gas. Okay, you know what that means? It's a little sensor that senses temperature, and if the compressor, the outside of this compressor gets really hot right here, the outside of this metal, there's a sensor that's located back here in the back of the compressor, inside of here, that's actually pressed against the body of the compressor and senses temperature, and if the compressor gets hot, it'll just break the wire so the system goes off. Understand? So, thermal overload. And the thermal overload can be tripped because somebody put the wrong fan on, or somebody put a fan motor on and they didn't get the rotation right, or they tried to change the fan blade and they didn't get that proper, or it's just filthy, okay, or the motor's burnt out, okay. That could cause high head, okay, and that could cause it to go over in thermal overload because it ain't cooling down. It ain't bringing the gas back cool enough to cool the compressor, and that will cause that issue. So I don't want to swarm your head, and I think we're going to stop there at this point.